So hey guys, this is Vishwit and welcome to my YouTube channel. So in this video, I'm going to continue with the previous video that I have explained regarding the machine learning project. So we were left with saving the model and the prediction on the test data. I'll try to keep the video as short as possible because we don't have much to explain over here. We have already created our machine learning model. We have found out how our previous model performed, how our current model performs. Since I don't want to run in front of you, so the model is actually not that great. We are getting around 81%. I will tell you to increase this parameter search. So for example 0.51, you can just increase these values as your wish, just increase or decrease. Okay, so that your model gets a good accuracy. Now the main part is you will get a good accuracy. So what to do next? You have the model, you have the pipelines. What to do next? So generally we have to save the models. Saving the model is extremely important because at the end of the day the model is something that you require either for deployment or for testing. So you don't have to train the model again and again. So once your model is trained, save it. So saving the model. So we are coming into this section now. This function I use it extremely frequently. This is something that I create. This helps to generate file names. For example, if I save the model over here, it is going to generate a file name based on current time and date, and it is going to add this in the date and time in front of your file name. So it is actually easier to know that which is the most recent file. Also, you can do one thing. You can just add the accuracy factor over here. Like for example, you're getting an 81% accuracy. You can add that also over here. So you will be able to know which model is giving you the highest accuracy, and you can save that. Isn't that awesome? Simply saving the model is extremely easy. First, what I have done over here, I use joblib because this is extremely easier for me. You can also use pickle. So joblib.dump, this is a pipeline. We need to save our pipelines also. Full pipeline, and this is the file name. This is the file name actually. So if I pass this to my function over here, full pipeline.pickle, it is going to generate the date and time, append it into my file name, and create one single name. So I'm going to explain this part, what this OS thing is doing. os.part.join pipelines get file name full pipeline.pickle. This part is going to generate my file name. This generate file name is nothing but this. So what I'm doing, I'm passing my file name over here, and it is going to return my file name with a date and time. Let me show that. For example, we have a generate file name, and I will tell as a model. If I do, you can see 2nd October. How can it be October? It's 11th February. Okay, I should give date over here, month over here, then it is going to be good. So if I do this, so 2nd February 2022, 1934, 734 over here while I'm recording. So see, this is the file name that got generated. Now the same thing I'm doing for my target encoder.pickle. Right? If I give target encoder.pickle, you're going to give this. It's easy. Now this is something that I explained, and I have to explain the os.path.join. So generally os.path.join, what it does, it creates directories. It creates the path. So for example, if I do os.path.join dir1 comma dir2, if I do this, you can see it created this path, this link. So this is actually extremely useful if you run your code on any platform. Like if I run it on Windows, it will give me this. If I run the same thing, like if I run this on Windows, since I'm working on Windows, you can see it gave me this. If I work on Linux, it will give me this. Okay, pretty easy, right? So on Linux, it'll give me this. On Windows, it will give me this. So that is something we don't have to do it from our end. We don't have to change the slashes. So that is why os.path.join I have used, because it is going to do it by itself automatically. So what it is doing over here, it is simply generating the path. If I show you this output, it is simply generating this path. So there is a folder known as pipeline folder. These are the pipelines that I have created. So there is a directory. So it creates, I mean, there is a directory, and these are the pipelines. So simply what this is going to do, it is going to say, it is going to create this particular link. This is the link. So our model gets saved under pipelines, and this is our model name. So this is why os.path.join I have used. Pretty simple, and this is the value of our pipeline. The same thing we are doing for our target encoder. And similarly, the same thing we are doing for our best estimator, that is our best model. So this is our best model, and I'm just doing the same thing, and I created a different folder known as model, and the model gets saved over here. So if you face any kind of issue saying that pipelines folder not found or model folder not found, just create it. I have not written that code that it will automatically create it, but you create it from your own. I think that much you can do. So here I have printed a message that pipelines and model got saved. Now, prediction on the test data. This is the data that we downloaded from here, adl.test, right? This is the data we downloaded, and this was already saved. This was the training data, and this was the test data. Okay, let me show that data. I don't want you guys to get confused. So this is the data set. This is the data on which the model is trained, and this is the data on which we are going to perform testing. We have already done a small testing that I have showed, and this is going to be a full-fledged testing. So if you watch the data carefully, adult test, you can see these are my data that is provided, and this is the target that they have provided. Fortunately, they have provided a target also. Okay, because this won't be there when you are doing the test thing. They have provided the target. That's actually good. Now what we can do, we can read the training, we can read both of the data separately. Like they have provided this data, the actual data, and they have provided it. They have also provided the target. So we can read this separately and this one separately, and we can verify with classification report and confusion matrix. So that is what I have done. So I have read that test file. I have stored all the columns in my train, and I have stored the target in my test. This won't be available, but fortunately it is there for us because this is a toy data set. This is there for us, so we can test. So this is how our test data looks like. I mean, this is how our train head looks like, and this is how our test head looks like. Now you can see lesser than equal to 50k dot. There is a dot. We have to handle this dot. We don't want dots to be there because previously dot was not there. Now dot is there. We need to handle this dot. So I have written this script. It is handling all the spaces, all the dots, everything. Now I am loading our transformers that is present, or I can save the pipelines that we saved. I am simply loading the pipelines These are the pipelines that I'm loading. I'm not executing my code because it is going to give me error because I have not done the grid search. So there is no best model. So, but I think I will be able to run the test thing. Yep, I will be able to run this. Okay, let's execute this part. Yep, because the model is already saved. I can use the old model. So this is the prepared data that I have. Okay. So full transformer dot transform, we are supposed to use dot transform over here, and this is the train. Okay, train means this data. This data. I think we did some pre-processing over here. So this data. Okay. So we removed the full stops, the spaces, everything we did on the train and the test data, and I'm reading this train data, right? This train data. So I'm reading and I'm transforming the data, right? We need to scale, one or encode, all those things we are doing over here in one line. We're supposed to use dot transform because our model is already fitted using that train data we used before the machine learning part. So we are supposed to use dot transform. This the prepare data dot to array. So this is the data that we have. This is the test data which we are going to test with. Yep. Now this data should not be there, but it is given. That is the target value is already given. So I am also using the target value. I am transforming the target value, right? So the target value is given as lesser than greater than 50k. We need to we need to transform that data so that we can utilize that data. So this is our prepared target. This is the data. Now I am loading the model, the best model that we found out. I am making the prediction on the model over here, and it gave us this as the prediction. And I'm printing the classification report, and it is giving us an 85% F1 score. It is going to give a bit good score because I have already trained the model before. So F1 score is little bit higher. But if you increase the sample space, as I said in grid search, you will get much higher F1 score, that is accuracy. So now the confusion matrix, this is the confusion matrix. You can see we have a good amount of value over here. Okay, so we are like, there is some issues with our model, so our model can be better. So I have to run a proper grid search. Okay, it is going to take me an hour or two, and it is going to give us a good confusion matrix, definitely. Now, as I said, this is the prediction that it made. Now, what is the use of this? We don't know how to use this, right? So we have to do some kind of inverse pre-processing. So we have done one pre-processing, we have to do inverse pre-processing. So for that, we have this target transformer, which is nothing but our target transformer, because by the name it goes target transformer. Yeah, inverse transform ypred. Ypred is nothing but the prediction that it made. This is ypred. Now dot inverse transform ypred, it is simply going to give us an array. This is nothing but the actual predicted value. This is the predicted value 0101, but we don't know for which it is saying 0, for which it is saying 1, because 0101 doesn't make sense to us. It makes sense to the computer. So for us, it is lesser than 50, lesser than equal to 50k, greater than equal to 50k, greater than 50k. This is the value that it makes sense to us. Now, to make more, to give you more clarity, what I have also done is I have created a data frame. I am executing all of that. Yep. Now this our job is done. This is what you are expected to do. This is how much you have to do, right? This is what that you are looking for. That the output for your test data. To make things little bit clear, what I have done, I have created a data frame, and this is the thing. See, this is the age, work, class, education. This is the data that is provided. This is the actual value, actual income. Actual income means uh, this is nothing but our test data, which is lesser than equal to 50, lesser than equal to 50, greater than 50, lesser than 50, lesser than 50, greater than 50. This is our this file only, our test file only, adult test. So this is the actual income, the actual value that is present over here that they provided. This value is nothing but this value, actual income, and this is the predicted income that we did, that the model did. So lesser than equal to 50, then greater than 50k. Here you can see it missed out. Then rest all is, I think it's fine, but still there are errors obviously because our model is 85% accurate. So this is what I wanted to explain. So this is our actual value, and this is the predicted value. So this is the last phase, like that I wanted to show you so that you are able to understand clearly that what we are doing, because even I got confused when I stuck on this, like I got 0101, what I'm supposed to do next, how I get my original values back. So using the inverse transform, you will get your original values back. So this is how things work. So I hope you are able to understand the Jupyter notebook file. I mean this code, this Jupyter notebook script that I have written. So next we are going to go into the deployment part, where I'm going to show you how I have done the deployment, how the app looks like. So if you are able to understand this, so give a like, and if you have any kind of doubts, do comment me. And thank you for watching. We'll see you in the next video.